Alright, John, so now I'm looking at the final portfolio, number 16, and it says, which graph represents a sound wave that follows a curve whose period is pi and that's in the form of y is equal to a sine bx. So the reason why they're telling you that second part is because it's obviously a sine curve. If it was a cosine curve, they'd say y is equal to a cosine bx. So what you can do for options A, B, C, and D, because this is a sine curve and not a cosine curve, we know that sine goes right through the origin because it starts at 0 and it goes, ends at 0 and all that stuff. So you can cross off option B right away because B is clearly a cosine curve because it starts up high at its maximum. The rest of them look like they're sine curves, so we just have to figure out which one is the right form. Now, all of those curves, you can see that you can see the range between 0 and 2 pi. So the period, that's not really extremely helpful. It just tells us that how long does it take to see one curve between 0 and pi. That's kind of helpful, but it's actually more helpful if we think about it in terms of the frequency instead. So if the definition of the period is 2 pi over b, and in this case we know that the period is equal to pi, I can solve this equation. I can put this over 1 and cross multiply, and I can figure out what this b is. I can figure out what the frequency is. And then all that will tell me is the frequency is how many curves you see between 0 and 2 pi. So once we know what b is, we can just count and pick which one is the answer. Because choice A, I see 2 full curves between 0 and 2 pi. Choice C, I only see 1 curve. And then choice 3, there's 1, 2, 3 curves. So whatever b turns out to be, it's going to tell us what our answer is. So I'm going to cross multiply 2 pi is equal to b pi, and because there's a pi on both sides, I can cancel those out, and b is equal to 2. So we want the option where you see 2 full curves between 0 and 2 pi, and that is A. So A is our correct answer. Okay? Number 17 is kind of similar just because it's dealing with trig graphs again, and I know that those weren't your favorite. So the curve shown below is either a sine curve or a cosine curve. State the equation of the curve. And this is kind of what it looks like. Let me just draw a quick sketch of what you see on that paper. So you can see that the curve has a maximum of 2 and a minimum of -2. And then this graph actually goes all the way out to 4 pi. So you really have to be careful. A lot of the kids taking this test made mistakes because they didn't look to see what was on the x-axis. And they were like, oh, okay, so I look at that picture and I see 1 full cosine curve. But in reality, the definition of a cosine curve is, something, or not the definition of a cosine curve, but it's between 0 and 2 pi. And because this is between 0 and 4 pi, you just have to be a little bit more careful. So what I told the kids is because we were really used to just looking between 0 and 2 pi, I kind of just told them, let's just forget about everything else that you see. Let's just kind of like, you can put a piece of paper over it, or you could, I don't know, erase it or box it out or something. But just don't look at this whole section right here. I'm going to see if I can color this in. Really? Aha! Look at that. Fancy. Alright, so forget about the rest of that stuff. Okay. So I need to know what the equation of this curve is. Okay. Well, this is obviously a cosine curve because it starts at its maximum. So the equation of a cosine curve looks like this. Y is equal to a cosine bx. So we need to know what A is, we need to know what B is. Now, A represents the amplitude. A represents how high it goes and how low it goes. So the maximum on this is a 2, the minimum on this is a -2. And amplitude is always the absolute value. It's always positive value, so the amplitude is 2. Now B is what we talked about just before in the other question. B is the frequency. B is how many curves do I see between 0 and 2 pi, which is exactly why I had you block this whole thing out, because frequency is only between 0 and 2 pi, not between 0 and 4 pi. So how many cosine curves do you see in this interval? I don't even see one full one. Actually, that is a half of a curve. So our B is 1/2. So that means that your equation can be written as y is equal to 2 cosine, and then you could write it as 1/2 x or x over 2, either one. That's the final answer. Okay? Now, on the very last page, we have another question, number 18. The graph of which function has an amplitude of 2 and a period of 4 pi. So if I'm looking at all my answers, A, B, C, and D, the fact that they said an amplitude of 2 lets me cross off A and D automatically, because both of those have a 4 out front. So those are clearly not the right answer. So we are left with two different answers. Y is equal to 2 sine 4x and y is equal to 2 sine 1/2 x. So the other piece of information that they gave us was that the period is 4 pi. So if the period is 4 pi, and I know that I have an equation to figure out what period is. Period is normally 2 pi over b. Then I can put this over 1, cross multiply. And the reason why I'm cross multiplying is because, yet again, I want to know what that b is. Why do I want to know what that b? Because the b is this part of the equation. So whatever I get for an answer, I can then choose the correct option. So this is 4 pi times b is equal to 2 pi. They both have pi symbols, so I can get rid of that. So 4 pi is equal to 2. I can divide by 4. B is equal to 2 over 4, which is also equal to 1/2. So that means that choice C is the correct answer. This is my equation. Y is equal to 2 sine of 1/2 x. Okay, awesome. Now, here's the deal with the last two questions, number 19 and 20. You have not learned how to do these yet. These equations, or these questions, come from questions in Chapter 14, which is trig applications. I'm going to start the videos for the trig applications tomorrow, but you don't know those yet. And I really want you to be able to finish your portfolio. So here's what we're going to do. I'm going to explain these concepts to you. You can listen and try to understand as much as possible. But don't worry too much about it, because I'm going to do a better job explaining it after I've gone through all of those notes. So I really am just doing this so that you can complete your portfolio, okay? So let's look at number 19 first. Don't tell Ms. Tompkins I'm doing this. Alright, number 19. Susan wants to build a garden in the shape of a triangle. So we always like to draw diagrams when we're doing stuff, just to help us. Interesting. Okay, she wants to build a garden in the shape of a triangle. Two of the sides are 12 feet and 11 feet. So one of them's 12, one of them's 11. If the area of the triangle is 60 feet squared, that's the area, find the angle formed by the sides that are 12 and 11 feet long. So the angle that's in between them, and find that to the nearest degree. Okay. I have no idea why I X'd out of the reference sheet, which is not good. So let me pull that up again. So while I'm doing this, just listen to me talk. hold on one second. Excuse me, sorry. In the Trig Apps chapter, we learn about the rest of the stuff, or a couple of the other things that are on your reference sheet. We learn about a new definition for area of a triangle. We learn about law of cosines and law of sines. They're really not that bad. But the area of a triangle, you're probably saying to yourself, I already know how to find the area of a triangle. It's 1/2 base times height. Well, the reason why we're not using that equation is because it was always really difficult for us to figure out what the height of a triangle was if it wasn't given to us. Because I'd have to somehow draw a line down here, and that would be my height, and I'd have to figure it out, and that's just not very helpful because they're telling us what the area is equal to. So that doesn't help me very much. So I have this new definition, and it's on your reference sheet so you don't have to memorize it, which is awesome. And they are calling it K is equal to whatever. It really just stands for area. The reason why they're using K is because a lot of the times the triangles, we label the vertices A, B, and C. So we just didn't want it to be confusing, so we're using K instead. I don't know. Okay, so the area of a triangle is K is equal to 1/2 AB sine C. Okay? So if I had labeled this triangle originally ABC, then the little a's represent the side lengths. So little a is across from angle A, so little a is 11. Little b is across from angle B, so little b is 12. And then the sine of angle C. So we know that the area is equal to 60, so we can kind of plug in all the things that we already know. So 60 is equal to 1/2 11 times 12 times the sine of C. And C is what we're solving for. Now, what you need to know is the only time that you're allowed to use this equation is when you have side, angle, side. Okay? The angle that's in this equation right here, it has to be the one that's in between the two other sides. So if you don't have the one that's in between the two sides, you can't use this equation. You have to find some other way to figure out what the other angle is. Okay? So, but because I have side, angle, side, I can use this equation. I already know that the area is equal to 60, but I'm using this equation to solve for the missing piece, which is my angle. So I can put all this into my calculator. So 60 is equal to, and then 1/2 times 11 times 12 is 66 sine of C. And I want to get sine of C by itself, so I'm going to divide both sides by 66. So, oops, I'm going to do 60 divided by 66. So this decimal right here is what sine of C is equal to. Sine of C is equal to 0.909, repeating. But I don't care what sine of C is equal to. I want to know what this angle C is equal to. So I can do second sine, second answer, because that decimal is still in my calculator, which is awesome because we don't really like to round halfway through. It's better if you keep it in your calculator and then do second sine, second answer. Hit enter, and then C is 65.38 degrees. And if you read the question, it says it wants the angle to the nearest degree. So C is equal to 65 degrees. Okay? So it's just another formula on your reference sheet, something that you do not need to memorize. It's right here for you. But the only thing important that you need to know is that the angle has to be the one that's in between the other two sides. Okay? That was number 19, and I have to stop right here.